60.
60. 30 plus 30.
And how many bones are there in our spinal column?
33. It's 26. 26 if it is fused, and 33 if it is fused, then 26. Otherwise, it is 33.
Very good for the clear explanation. And how many bones are there in the fingers, and what is their anatomical name?
Fingers are called phalanges. The
Yeah,
bones in
and
the
their count?
fingers are phalanges, 14.
Yeah, very good.
Tarsal 8. Tarsal 8.
Yeah, Kaliswari ma'am, please repeat.
Tarsal bones 8. Phalanges 5.
Yeah.
Metatarsal 5. Last one 14. 14, 5.
Yeah, very good. But I have only
Thank you.
4 fingers. Okay,
Ma'am?
okay. No problem. Thank you.
Thank you,
I
ma'am.
think you people understood it in last class. So now we will proceed to next. I'm sharing my screen. Is it visible?
Yes, ma'am.
Okay. Okay. So now we will proceed. On last class, we have discussed about lower limb. Now we will proceed to joints or articulations. Joints are known as articulations only. So a joint or articulation is the place where two or more bones come together. Okay. When two or more bones is coming together, that is known as joint or articulation. Joints are weakest part of skeleton. Joints, obviously, when two bones are meeting, there is not a hard part. They are just meeting. It's like when we weave a cloth, or when we make a cloth, just like a shirt is being made, and like our upper arm shirt, the upper arm of shirt is being stitched to the main body of shirt. So the portion where the stitching is done, that portion becomes the most weakest part of shirt. Every joint or every stitches is the most weakest part of every cloth. Like that only, joints are also the weakest part of skeleton. They give skeleton mobility and hold it together. Sorry. And 3 types of joints are classified by amount of movement they allow. Means this type of joint is classified by the amount of movement they allow. Okay. So these types are: first, immovable; second, slightly movable; third is freely movable. So immovable joints, for example, are fibrous joints. Means generally immovable joints are fibrous joints. Slightly movable joints are generally cartilaginous joints, and freely movable joints are synovial joints. Okay, freely movable joints are synovial joints, like our knee joint. Knee joint is freely movable. It is an example of synovial joint. Am I audible clearly?
Yes, ma'am.
Okay, thank God. On the basis of structure, this fibrous joint, which is immovable. Okay. And the example of fibrous joint or immovable joint is our sutures. Sutures mean the joints of cranial skeleton. Cranial means joints of our cranium or our head or skull. Skull is also known as cranium. So the joints of the bones of cranium is fibrous joint, or these are immovable joint. We all know that bones of cranium do not move. They are immovable and they are fibrous. The bones are joined by fibrous tissue. No joint cavity is present. We can feel by touching our skull that no gap is present in our skull. It is fully packed. It is fibrous joint. The amount of movement allowed depends on the length of fibers uniting the bone, that is sutures joint. Means obviously amount of movement allowed depends on length of fibers. As long means the length of fiber will decide how movement will occur or how much amount of movement will occur in the joint. Next, second one was cartilaginous joint. The articulating bones are united by cartilage. They lack a joint cavity. Here also we can't find a joint cavity. The articulating bones are united by a cartilage. Like for example, we can see here in between two vertebral column, in between two vertebra, there is a cartilaginous disc. You can see here in the picture, in between two vertebra, there is a cartilaginous disc, and this cartilage is connecting these two vertebra, and there is no joint cavity present here. And these cartilaginous joints are slightly movable. Like we can do back bending asanas, or we can do forward bending, we can do twisting. So these are slightly movable, not fully movable like our hand shoulder joint. This is our shoulder joint is ball and socket joint. Our knee is hinge joint. So these are freely movable, but this our vertebral column is slightly movable. This is cartilaginous joint. Okay, and next one is synovial joint. Synovial joint is articulating bones are separated by a fluid containing joint cavity. Means we can see here a joint cavity. A joint cavity is present in this type of joint known as synovial joint, and this joint cavity is filled by synovial fluid. Okay, so this is an important question. That a joint cavity is only found on synovial joints, and these joint cavities are filled by synovial fluid. All synovial joints are freely movable. Okay, all these synovial joints are freely movable. For example, ball and socket joints, pivot joints, hinge joints, gliding or plane joints, condylar joints, saddle joint. So these are the 6 types of synovial joints. So if we conclude the types of joints, then mainly there are 3 types of joints on the base of movement: immovable, slightly movable, freely movable. Now, this freely movable is synovial, and this synovial is further divided into 6 types: ball and socket, hinge, gliding or plane joints, pivot joint, condylar joint, saddle joint. So, on details of ball and socket joint. Head of one bone is ball-shaped and articulates with a cup-shaped socket of another. Like one bone is, the head of one bone is like a ball. The structure of head of one bone is like a ball, a round shape. And the another articulating bone means where two bones are articulating together. There, one bone is like a ball and another bone is like a socket or holder of that ball. Right? Means just like holding the ball like a hand. So we can see a ball shape bone and a socket shape bone. That is why it is known as ball and socket joint. Head of one bone is ball shaped and articulates with cup shaped socket of another. The joint allows for wide range of movement. This is the joint which moves the most. The range of motion in our body is highest in ball and socket joints. Okay, the joint allows for wide range of movement. The most freely moving synovial joints means obviously synovial joints are most freely moving. For example, shoulder and hip joints. Our shoulder joints and hip joints are the example of ball and socket joints. Means these four only are the ball and socket joints in body. Now, second one is hinge joint. Hinge joint where the bone can only move along one axis or flex or extend. For example, elbow joint and knee joint. Means in hinge joint, only one directional movement is there. Like we can see in our knee, we can fold the leg in backward only. We can't fold the leg forward because patella is there. Patella will restrict the movement of forward movement of our lower leg. And same thing in our hand, we can only move our hand in forward. We can't move our hand, means we can't move our lower hand backward because our elbow is structured in that way only. We can't move our lower hand backward. So this is hinge joint. Just like our doors open one side only. And that is why a hinge is placed on our doors. So our doors open in one direction only. Like that, the joint which is only allows flexion and extension movement. Only one directional movement is present. That is known as hinge joint. An examples are elbow and knee joint. Now, third is gliding or plane joints. Articular surfaces are essentially flat or very slightly curved and allow only short slipping or gliding movements. Means these articulating surfaces are essentially flat. Means they are literally means lightly flat and very slightly curved. They allow only short slipping or gliding movements. They allow only short movement and gliding movements. Like one bone is gliding on another bone. They much curvature is not there. Bones are almost surface is almost flat. Like we can see this type of movement in our carpals, means wrist. For example, intercarpals and intertarsal joints. Means in wrist and ankle too. Fourth one is pivot joint. The rounded end of one bone protrudes into a ring composed of one another bone. Means, let me explain by this. You can see my drawing here.
Yes, ma'am.
Yeah. Just imagine, my drawing is very bad. This is a type of bone and its head is covered by a ring-shaped bone. Okay, like this is a ring-shaped bone, and in between that ring, a hollow structure is present, and that hollow structure, on that hollow structure, this long type of bone is inserting and they are articulating and forming a joint. Okay, like imagine this is a bone of our this is a bone of our cranium or our skull, and this long bone which is inserting from the below or which is articulating or filling the hollow structure of this ring, that is our first cervical bone. Cervical bone is present on which area of our body? Please reply me.
Cervical. Neck,
That
neck
is which
region.
area?
Neck.
Neck.
Yeah, very good. Neck area is cervical area, and the first cervical bone is named by which
C1.
name? C1. Very good. So this is the condition of C1 and our atlas means our skull bone, where this spinal column is generating. By this articulation only, the spinal column is generating. Like our cranium is that ring, and this C1 is the inserting bone from below, which is covering or which is fulfilling the hollow part of this ring. This is the pivot joint. Okay, is it clear?
Yes, ma'am. So the rings are the
Yeah.
cervical bones, right?
No, this ring.
The ring around the rod-shaped bone. Those rings are the cervical bones, right?
Yeah. That rod shape bone was cervical bone. And
Then what are
this
the rings, ma'am?
ring is the first ring is the atlas. Atlas bone is one bone below the cranium.
Okay.
You can see here in this picture, like this is the atlas. This is C1. Okay, I'm really sorry. I think I have told you that C1 is the rod one. No, this ring is C1 and the rod was C2. Okay,
It's
is
not
it
clear,
clear now?
ma'am. Can you repeat that? No, it's not clear.
Yeah, the ring was C1. Here you can see atlas is C1. This ring sept, this is the hollow structure. This is the hollow structure. Okay, here pivot enters, and this bone which is containing this hollow structure is known as atlas, and this is the C1. Atlas is C1 bone, and the rod shaped structure which is inserting this ring shaped structure is that rod shaped structure is C2.
Then where is C3, ma'am? Where is C3 in the order?
Let me explain once more. This is C1 and this is C2. Okay, and below this there are let me draw it clearly. This is C1, ये C1 है, ये C2 है. इसके बाद below this structure of spinal cord is spinal column is continuing. Is it clear now?
So those rings below C2 are C3, C4 through C7, is it?
Yeah. So from C2 and C3, the joints are normal, like other articulating joints of spinal column. But the special one is between C1 and C2. That is pivot joint.
Just repeat that, ma'am. Just repeat what you said.
Yeah. In between C1 and C2, this pivot joint is observed. Like a rod is inserting a ring. So the ring one is C1 and the rod one is C2. And below C2, C3 is there, and C3 is a normal spinal vertebra. And from C3, the vertebrae are continued normally as we have seen earlier, as the shape of vertebra and the cartilaginous bones, cartilaginous cushion, all these are continued normally. The special one is C1 and C2. C1 and C2 is they are conforming pivot joint. Is it clear now? Hello?
Kind of, ma'am. I am not very clear with it, but I understood it partially.
Still not it is clear. Okay. Let me explain one more. I should try. This rod shaped structure is cervical 2 and this ring shaped
Ma'am, that
structure.
I have a question here. The
Yeah.
rod-shaped structure, which you're calling it as C2,
Hmm.
is only until where C1 ends. Not, it doesn't go down C3, C4. Are those structures the ring-shaped structures called C3, C4, and
No,
so on?
we are talking about only bones here. I think you are confusing with spinal cord. Spinal cord is a different. It is going through the hollow structure of all vertebra. Hollow structure is present in a different area of spinal bone. Means we here we are talking about only bones. And earlier we have seen that a hollow structure. Let me explain with that slide only.
Ma'am, 1 second, ma'am.
Yeah.
What I understand is like when just we can move our head both the sides and feel so that we can feel that point, right? I feel that is the pivot joint, right, ma'am?
Yeah, very good. You have got it.
Yes, ma'am. So when we move the head and see, no, I am able to feel the point, like so that I am getting.
Yeah. Here you can see. It is a normal spinal vertebra. Here you can see that the below part is the frontal side of body and the upper part we can see in the let me okay, you can see here the lower part in this PDF. In this lower part we can see a large uh, a semi-spherical shape you can see here, that is known as body of vertebra. It is leveled here. The body of vertebra you can see here.
Ma'am, the slide that you're showing shows the entire skeletal system, and if you can turn uh, the PowerPoint deck.
Is it okay? Is it okay now?
We can't see your slides now. Yeah,
Okay.
now we can see it.
Okay, okay.
Yes, ma'am.
Now is it
No,
clear?
again the yeah, now
What's
it's better.
what's happening today? Is it clear now?
Yes, ma'am. But we yeah, go ahead, ma'am.
Okay, okay. Okay. So here you can see a normal structure of spinal vertebra. In the lower part of slide, you can see a large structure labeled as body, right? You can see the body of spinal vertebra.
Yes, ma'am.
So this body is at the abdominal side, or it is the frontal side of spinal column, and the spinal process which is pointing upward in the slide, you can see the spinal process
Yes, ma'am.
pointing upward in the slide. This is the back side of our spinal column. Means if we can, if we touch our backbone, then we can feel the spinal process. If we touch our backbone, we can feel our spinal processes of each vertebra, right? So this spinal process is the back side or dorsal side of spinal column, and this body is the frontal or ventral side of spinal vertebra. Now you can see a hollow structure is present in between this body and this spinal process and transverse process. The left and right are two transverse processes. You can see, just like spinal process in the back side, you can see two transverse processes are also there in this spinal column, left and right. And in between these, a hollow structure is present. It is white colored, hollow structure, so white colored. It is labeled as vertebral foramen. Is it clear? A hollow structure is present in between body and this spinal processes, that is labeled as vertebral foramen. We have already discussed earlier, foramen means cavity. Is it clear?
Yes, ma'am.
So our spinal cord goes through this vertebral foramen. When a series of vertebral column or series of vertebra is present, a long hollow structure is being appeared, or a long hollow structure is being prepared by this vertebral column. So through this long foramen of all vertebral column, all vertebral spinal vertebra, our spinal cord travels. Is it clear now?
Yes, ma'am.
Okay. Okay. So this is a normal structure of spinal vertebra. Now, in case of C1 and C2, there is a bit different structure we can see. Like we can see in this structure. Yeah. Now the slide is clear.
Yes, ma'am.
You can see in this diagram, the above bone you can see here is C1, and below C1, C2 is present. Here two bones are shown only, C1 and C2. So you can see the foramen in between them. This foramen is for spinal cord. You can see the hollow area in between these bones. Means these bones are forming one channel, and this channel is for spinal cord, but this blue colored channel is for pivot joint. This blue colored, specially shown in blue colored channel, this is pivot joint. I will show another very clear picture of pivot joint from Google. That will be very clear for you. Generally, you can see here by this structure that pivot joint is like that. Like one rod is covered by that only. For that joint only, we can move our head from left to right, because on the axis of C2, C1 is surrounding. C2 is the axis, and on the axis of C2, C1 is placed, and C1 is moving left to right on the axis of C2. You can see here. And I will show you, or I will send you a clear structure of pivot joint so that you can understand very clearly. So don't be confused. If you don't get understand, then I will also explain in the next class. And now my battery is about to dead, so I think now I should stop here. I'm sorry for the incompletion of slide, or I should complete this 6. I think I should complete. Are you guys okay with these joints?
Yes, ma'am.
I think pivot joint is not crystal clear for you. I will
Yeah.
make this understand. Don't worry. I'll make you people understand. Over
Your
in
voice is
another,
not clear, ma'am.
both articular surface. Yes. Hello.
It was not clear, ma'am.
No problem. Okay. So,
Ma'am, try talking now.
condylar joint. Yes.
Yeah, you can try.
Yes.
I just said the voice wasn't clear. You can try talking now. I think it's better now. Please go ahead.
Is it clear now?
Yes.
Okay. Condylar joints. Oval articular surface of one bone fits into a complementary in another. Both articular surfaces are oval. Both articular surfaces are oval. Like you can see here in between carpals and these metacarpals. Metacarpophalangeal joint. Metatarsophalangeal joint. Means carpals and metacarpals and phalanges. The articulating surface between metacarpals and phalanges is example of condylar joint. Here, both the surfaces are oval, so they are complementing each other. Like you can see here in this example, both the surfaces are oval, so they are complementing each other. Like a very light version of ball and socket joint. Very light version of ball and socket joint. Both surfaces are complementing each other by their curvature. Both are oval in shape. A very slight convex and concave structure of both bones. Okay. And next one is saddle joint. Saddle joint resemble condylar joint, but they allow greater freedom of movement. Each articular surface has both concave and convex areas. For example, carpometacarpal joints of thumbs. Means these saddle joints resemble like condylar joints, but saddle joints allow much freer movement than condylar joints, because the both surfaces are having convex and concave structure. Like, for example, carpo-metacarpal joints. So, the joints between carpals and metacarpals is the example of saddle joint. Okay. Okay. So, these are the 6 types of joints of synovial joint. 6 types of synovial joints we have studied today, and division of joint on the basis of range of motion. So this is that's all for today's class. And my phone is about to
Ma'am,
dead.
can you show me saddle brown?
Saddle, yeah. Here, saddle joints are carpo-metacarpal joints are example of saddle joint. Means joints between carpals and metacarpals. They
Okay.
allow greater freedom of movement than condyloid joints because each articular surface has both concave and convex areas. Okay, is it clear?
Okay, open.
Okay.
Yes.
Getting any question? I think I should leave now. So I think we should conclude with prayer as soon as possible. My phone is about to dead now, and there is no electricity till now from yesterday. So sit comfortably, upright your spine, close your eyes, adapt Namaskar Mudra, and repeat the prayer. Om Sarve Bhavantu Shukhinah Sarve Shantu Niramaya Sarve Bhadrani Pashyantu Ma Kashit Dukha Bhag Bhavet. Om Shanti Shanti.